Welcome to The Explainer. Today, we're turning our analytical lens onto a material that literally defines high performance. We're going to ruthlessly judge one of the absolute strongest materials in modern engineering, and I mean it, we are doing this with zero mercy. We are talking, of course, about carbon fibers. So picture this, a material that is 5 times stronger than steel, but somehow 5 times lighter. I mean, it sounds like something straight out of a sci-fi movie, right? But it's totally real. And the big question we have to answer today is this. Is this elite reinforcement the undisputed S-tiered champion of composites? Or is it just a really high A-tier specialist? Okay, let's dive into this and look at exactly what this material is on a microscopic level. It basically relies on incredibly thin strands of perfectly aligned carbon atoms all locked into a tight crystalline structure. Now, they're usually made from precursor materials, stuff like PAN, which is polyacrylonitrile, or pitch. These tiny, fragile strands are then combined with polymer resins to create those ultra-strong composites we actually see out in the real world. To figure out where it ranks, we're going to run it through our Anatomy of a Champion report card. We'll hit the historical breakthrough, check out those elite engineering specs, map out its modern dominance, expose its Achilles heel, and finally give our definitive tier verdict. First up, Section 1, Historical Breakthrough. From space-age niche to engineering stable, we're going to trace exactly how this stuff made it out of the lab. Looking back, the evolution here is actually pretty wild. In the 1960s, the first commercial carbon fibers popped up in the UK and Japan, strictly for aerospace. And hey, quick fun fact for you. The original fibers were actually made by heating rayon inside a vacuum. Crazy, right? By the 70s, it jumped to military jets and racing cars. The 80s brought it into Formula One and premium sports gear. Then in the 2000s, it went mainstream in civil aviation with planes like the Boeing 787. Now, in the 2020s, its biggest single job is actually reinforcing those massive wind turbine blades. Moving on to Section 2, Elite Engineering Specs, or the Anatomy of a Champion. Let's look at the raw mechanical stats that give this material its undeniable power. 7 gigapascals. That is its ultimate tensile strength. Just to put that into perspective for a second, it absolutely crushes steel by weight. When you need a material to resist being pulled apart, carbon fiber just operates in a completely different, almost untouchable league. But pure strength isn't the whole story. It's also incredibly light, with a density of about 1.8 grams per cubic centimeter. It has outstanding fatigue resistance, meaning it can take cyclic stress over and over and over without wearing out. Add in nearly zero thermal expansion, so it won't warp in intense heat, plus excellent corrosion resistance. Oh, and because you can specifically weave it or lay it down to handle targeted stress, it really is the ultimate lightweight reinforcement. So, Section 3, Modern Dominance, where carbon rules today. Let's explore exactly where this super material is deployed right now, as of March 2026. 150,000 to 180,000 tons. That's the global annual production right now. Actually, think about that scale for a second. For a material that used to be a rare experimental luxury, that is insane modern demand. Industries are just clamoring for it to push the limits of what's possible. Let's move to and see how this builds across different industries. It's the literal backbone of commercial aerospace and offshore wind farm blades. It's stripping heavyweight out of EV chassis and supercars, dominating high-end sports equipment like bikes and tennis rackets, and even being used to strengthen bridges and retrofit buildings for earthquakes. Plus, looking at the major 2026 trends, we're seeing hybrid composites using recycled carbon fiber absolutely taking off across all these sectors. All right, Section 4, the Achilles heel, the brutally honest truth. Let's drop the awe for a second and get into clinical reality. Why hasn't this stuff replaced every single piece of metal on Earth? Well, for all that incredible strength-to-weight ratio, carbon fiber has some glaring drawbacks. Mostly, it is exceptionally expensive and severely brittle. You see, metals bend or dent when they're pushed past their limits. Carbon fiber, it doesn't yield. Under a sharp compression or blunt impact, it just fails, suddenly and catastrophically. And this brilliantly illustrates why it's a premium choice, not an everyday one. There are massive environmental and manufacturing hurdles. Recycling high-quality fibers is notoriously difficult.
Making it in the first place is incredibly energy intensive. It also has what's called anotropic behavior, which just means if you stress it against the grain of the fibers, it's remarkably weak. On top of all that, the supply chain is completely dominated by just a handful of major producers worldwide.
So Section 5, the final tier verdict. Let's tally up the criteria and deliver our final ruthless placement for carbon fiber.
Here's the exact breakdown. It absolutely dominates in mechanical properties and lasting relevance today, scoring massive 9.5s. It's incredibly versatile, earning a 9.0, and gets an 8.5 for tech impact. Workability sits at a solid 8.0. So the crucial point is right here, scalability and cost, a measly 6.5. The sheer expense and the absolute nightmare that is recycling it really drag down what would have otherwise been a perfect score. So, the final verdict? Carbon fiber lands firmly in the high A tier with an 8.5 out of 10. Listen, if fiberglass is the affordable, reliable workhorse of the structural world, carbon fiber is the undeniable premium athlete. It defines modern high-performance engineering. Which leaves us with this one provocative thought. Will future recycling innovations and dropping manufacturing costs eventually elevate carbon fiber to its ultimate S-tier destiny? As we move toward a lighter, much more sustainable future, this material is going to be absolutely essential, but it's got to overcome that Achilles heel first. Thanks for joining me on The Explainer today. Think about that, and I'll see you in the next analysis.